Welcome to Open Box Education. In this video, I am going to explain about Introduction to the Probability. If you like this video, please subscribe to my channel and share to your friends. The term probably, in all likelihood, or a chance, or odds in favor, or odds in against are too familiar nowadays, and they have their origin in a branch of mathematics known as probability. In recent time, the probability has developed itself into a full-fledged subject and become integral part of statistics. The theories of testing hypothesis and estimation are based on probability. So the terms in all likelihood or a chance or odds in favor or odds in against are known as probability. So here the probability is divided into two types. So they are a subjective probability and next one is that objective probability. So when you are going for subjective probability, it is basically dependent on personal judgment and experience, and as such it may be influenced by the personal belief or attitude and bias of the person applying to it. So this is nothing but subjective probability. And coming to this objective probability, it is the probability that an event will occur based on an analysis in which each measure is based on a recorded observation or a long history of collected data. This is the objective probability. So this is the difference between subjective probability and objective probability. So here this subjective probability is beyond the scope. So here we are going to discuss only that objective probability. In order to develop a sound in probability theory, so it is necessary to get ourselves familiar with few terms. So the first term is the experiment. An experiment may be described as a performance that produces certain results. So here a performance will produce certain results. Generally we will call it as a experiment. So when you are tossing a coin, you will get either head or tail. So here the tossing is nothing but an experiment, so which gives a result either head or tail. And next one is that random experiments. So an experiment is defined to be random if the result of the experiment depend on chance only. So for example, tossing a coin or rolling a dice. For example, if a coin is tossed, then we get two outcomes, head and tail. It is impossible to say in advance whether a head or a tail would turn up when we toss the coin once. Thus, tossing a coin is an example of a random experiment. Similarly, rolling a dice is an example for random experiment, and drawing items from a box containing both defective and non-defective items, this is also example for random experiment, and drawing cards from a pack of well shuffled 52 cards. So all these are random experiments. And next one, events. The results or outcomes of a random experiment are known as events. Sometimes events may be combination of outcomes. So here the events are of two types. One is simple or elementary, and second one is that composite or compound. So an event is known to be simple if it cannot be decomposed into further events. That is, here we cannot divide the event into further events. So for example, here tossing a coin once provides us two simple events, namely head and tail. So this will not be decomposed into further. So this will be called as a simple or elementary event. On the other hand, a composite event is one that can be decomposed into two or more events. That is, tossing a two coins, so we can divide that events into further events. That is, tossing a two coins, we will get head tail, tail head and tail tail. So here we are decomposing that events into further events. So this will be that example for composite or compound events. And next one is that mutually exclusive events are incompatible events. A set of events A1, A2, A3 is known to be mutually exclusive if not more than one of them can occur simultaneously. Thus, occurrence of one such event implies the non-occurrence of the other events of the set. Once a coin is tossed, we get two mutually exclusive events, head or tail. So like that we can define mutually exclusive events are incompatible events. That is, here head and tail, these two are incompatible events. And next one is that exhaustive events. So the events A1, A2, A3 are known to form an exhaustive set if one of these events must necessarily occur. For example, the two events head and tail when a coin is tossed once. So when a coin is tossed, only we will get two events, either head or tail. These two are exhaustive events because they are necessarily must occurred. And next one, equally likely events are mutually symmetric events are equiprobable events. The events of a random experiment are known to be equally likely when all necessary evidence are taken into account. So no event is expected to occur more frequently as compared to the other events of the set of events. The two events head and tail when a coin is tossed is an example of a pair of equally likely events because there is no reason to assume that head would occur more frequently as compared to tail. So like this we can define that equally likely events are mutually symmetric events or equal probable events. That is, if a coin is tossed, we will get that head or tail. So there will be a probability for the head 50% and there will be a 50% probability for tail also. So like this we can call these two events are equally likely events. That is 50% for head and 50% for tail also. So we will call this as a equally likely events. And the classical definition of a probability. So the probability of occurrence of the event A is defined as the ratio of the number of events favorable to A to the total number of events. It will be denoted by P of A. So it is given as P of A equal to number of equally events favorable to A by total number of equally likely events. So this is the classical definition of the probability. So thank you very much for watching this video. To watch more videos, please subscribe to my channel Open Box Education.